Test scenarios like this really make me think. Check this out. 60 volts in that cell and I have 200 milliamps. What's also interesting is the milliamps at the cell, which is extremely low right now, but what's that? Just a little over half an amp at 32 volts. And we get some production here, appropriate for that voltage level, let's say. But I really wonder, like, what could I do dumping 60 volts into this? 100 volts into this? Like, that amperage is so low. At this scenario, I could dump tons of voltage into that primary. And I really wonder what kind of production that would translate to. It just happens to be this specific configuration here. If I pan out and just hold that maybe slow enough here, you'll see that the diode is in the traditional location here. It's my primary bifilar mode, secondary bifilar mode, and with essentially current respective here, the diode is on this north end here, positive end, whatever, feeding into our cell. Because this inductor's bridge, there is no inductor on this north end. Oh, there is no inductor on this north end. Wait. So, that's even kind of more wild here. What the hell? So, on the negative end of this thing, this brown output here, this goes to this custom wound inductor that I had made. So, it goes into that inductor, and that's the only inductor, aside from the secondaries bifi, but it's on the same one. So, we just have one huge inductor for the negative and no inductor at the positive end of this thing. That's really wild. We don't quite get as high as voltage we want to, but we do get a decently high voltage at extremely low input amperage with EOP. Very interesting scenario.
This is Stan's Revenge.
Now arriving at EOP. This is the ideal one right here, guys. I'm going to document this. Yeehaw, that's definitely 1/3 of an LPM right there. We are tipping over our 1 amp at the cell just by 100 milliamps. I hope those diodes can hold out. They're rated for 1 amp. But 7 amps in at 32 volts. Noting again that these two diodes here, fast recovery, are really nice. Fourth configuration, diode in the normal position, current respective. Balancing inductor on the north end just after the diode. No inductor after the secondary, so no inductor B, it's just straight bridge to the cell. So these interesting little doodads here, these two LEDs, are wrapped around one way in the opposite direction, as you can see from the black and red here. No diodes, no nothing, just an LED wrapped around it, and these cables is basically connecting the circuit. And I've noticed here that when I have the polarity normal on this thing, I get both of these LEDs to illuminate as if current flow is happening in both directions. On and off cycle, perhaps simultaneously. Could be because the equal opposite here we have, but we just a bunch of noise. If we were to flip that primary polarity, that's when we get our nice equal opposite. But you'll see only one LED is illuminated in this scenario. Interesting. So when we get this nice beautiful EOP that obviously gives us the best production, when we take the circuit back to normal polarity for the primary input, we get this crazy waveform here, a lot of noise and whatnot, feedback, and we have both illuminated. Interesting.
This is Stan's Revenge.